Hello everyone. Like many of you, I love buying all sorts of trinkets online, and various devices for cleaning, disinfecting, and overall tidying up are my weakness. That's why I have a bunch of vacuums at home for different tasks, including a robot vacuum, a huge garden blower, which is also a leaf vacuum, a window cleaning robot, an automatic trash can, and much more. Just recently, the mighty power of advertising made me buy this blower. It's a small battery-powered gadget that blows with incredible force. They are used for cleaning snow off cars, blowing dust out of computers, and other tasks. There are plenty of blowers on the internet, but this one impresses with its technical specifications and compact size. There are bigger and more powerful options, but their price can exceed a couple of $100. So, I decided to get the cheaper one, for myself. After receiving it, I decided to record a full review with a teardown, an examination of the internals, and to show the real capabilities of this little device. But first, I want to note that this video is not an advertisement. I bought this with my own money for personal use. However, there will still be an advertisement, though not for a specific product. I just wanted to remind you, once again, that the so-called Great Chinese Sale has started, and on AliExpress, it's rare, but you can find products with real discounts. In any case, I have compiled my top products for radio enthusiasts, and will leave all the links in the description. By purchasing through these links, you help support the channel's development as the author earns a small percentage from it. So, blowers of this type can have different configurations, including an attachment that allows the device to be used as a vacuum cleaner, which is quite convenient. My version actually comes with such an attachment. When looking at the photos, I initially thought that the device's body was 3D printed, as there were layers characteristic of this method. But after receiving it, it became clear that this was not the case. It's just the design. Otherwise, it's pure casting. It comes in a fairly high-quality box. Inside, you find the blower itself and the power cord. In my case, there is no power adapter. In a separate box, there's an attachment that turns the device into a mini vacuum cleaner. There is also a not very informative manual, which states the battery capacity as 8,000 mAh, which is not entirely true. Charging time is 2.5 hours. The device weighs 300 grams. On the seller's pages, more detailed technical specifications are provided, such as the motor type, brushless, the motor speed, which is fantastic at 110,000 revolutions per minute, the battery life, 10 to 15 minutes, and the theoretical wind flow speed from the nozzle, 45 to 50 meters per second. The parameters vary, and it all depends on the seller's greed. The nozzle is removable. The vacuum attachment is installed at the back. There is a USB Type-C port at the bottom for charging the battery, and there is a start button. To start the device, you need to press and hold this button. It doesn't start immediately, but after a second or two. There is a motor speed control on the side of the handle. In maximum mode, when starting, the flow is so strong that it jerks your hand back. Of course, 110,000 revolutions is no joke. Even without disassembly, you can see the turbine, and it's aluminum. Inside, there is a green backlight that is active only when in operation. Let's conduct a few tests, and then we'll disassemble it to study the internals. Before each test, I fully charge the battery. The motor is voracious, and the battery won't last long. We'll measure the airflow speed using an anemometer. Of course, the measurement is purely demonstrative, so don't expect high precision, but we'll be able to get a rough idea of the airflow speed. At a distance of a couple of centimeters from the anemometer sensor, the airflow speed is over 40 meters per second, and the device maxes out. In the real world, wind over 30 meters per second is rated at 12 on the scale and classified as a hurricane. And here, it's over 40. So, draw your own conclusions. Many people likely use scales for measuring thrust with a hemispherical vessel and blow into it, measuring something in kilograms, or, even without a vessel, just on the scales pan. I don't know what that shows, but let's not fall behind the trend. engine revolutions and other aspects, we will try to measure after disassembling the device. And before disassembly, I'll show what this tiny blower can do. First, about the vacuum cleaner mode. The nozzle attaches at the back and snaps into place. There's also this metal piece here, which acts as a check valve to prevent debris from coming back out after the vacuum is turned off. But the metal piece is heavy and significantly loads the motor. Overall, in vacuum cleaner mode, the motor noticeably overheats due to insufficient airflow for cooling. Only while editing the video, looking through photos on the seller's pages, did I realize that the metal piece is not a check valve at all. And it's placed in the nozzle to reduce the airflow blowing in your face when used in vacuum cleaner mode, which makes sense. But my way of using it isn't that either. In any case, both uses overload the motor. Actually, as a small vacuum cleaner, it works quite well. True, the container is a bit small, but the device itself is also small. Therefore, there can be no complaints here. It works much better than similar, cheaper vacuum cleaners. The container is easy to remove and clean. Of course, the filter here isn't grade N, is quite small. Small dust particles will continue to pass through and go through the turbine, eventually settling on some parts of the motor and being expelled. On the other hand, overall, the vacuum cleaner is just for show here. Here in these shots, our mini blower against sleet. Blower against water. Blower against even more water. Blower against various objects. Well, now, as is tradition, let's take apart the device to study its insides. Inside, everything is quite advanced, except that at some point, something went wrong, and the Chinese poured in super glue to stick the parts of the casing together, even though there are clips provided here. Everything else is screwed together using a bunch of small screws. Inside, we find 3 boards, the motor itself and a rechargeable battery. The first board, located at the bottom of the handle, is the charging system. The charging system is based on the intelligent chip IP2326. The charging module is standard and can be purchased separately, but it's quite interesting. First of all, the battery here is 2S, which means 8.4 volts. Your handy charger might only provide 5 volts, and that's not enough. Therefore, the charging module used is a step-up module. It boosts the 5-volt input voltage to 8.4 volts, provides a stable charging current, charge process indication, and much more. The chip used, by the way, can also charge 3S lithium, which means 12.6 volts. The module also supports fast charging protocols like quick charge. It also allows for the connection of an external temperature sensor for temperature control, for example, on the battery. But there is no thermistor here. An important point is that this module is a pulse module, built on a highly efficient synchronous topology, and the efficiency reaches up to 94%. The maximum charging current is 1.5 A. The maximum power is 15 W. It has built-in thermal protection, overload protection, and short-circuit protection. Overall, considering its simplicity and low cost, this is one of the best solutions available today. I'll give it a thumbs up here. Next, the battery pack. It is in heat shrink tubing and uses 21,700 standard cells. Before removing the heat shrink tubing to see what cells are used here, let's conduct a consumption current test. For this, I fully charged the battery, then set it to the maximum power mode. I attached the current clamps and started the engine. As we can see, the clamps show a current of over 24 amps. In real conditions, due to the narrow nozzle, the load on the engine will be greater, and accordingly, the consumption current will increase. If we consider the average voltage on each cell to be 3.7 volts, and there are 2 of them here, and they are connected in series, along with the consumption current, then our system consumes about 185 watts of power. And these are not the manufacturer's words, but honest figures that we obtained during the tests. Even taking into account the efficiency of the driver and various losses, the engine clearly consumes at least 150 watts with such power. If you look at the engine itself, you can see that it is small, but it is wound with wire that is not of a child's thickness. There is an engraving on the engine with the main parameters. This engraving is very neat and precise. Here, in addition to hieroglyphs, there are also numbers that indicate the motor is exactly 140 watts at 7.4 volts. And the most important thing is the RPM. A whole 110,000 revolutions per minute, and I am inclined to believe it. The engine is housed in an aluminum sleeve, which serves as a cooling radiator. The turbine, or propeller, or fan, call it what you will, is made of aluminum and appears to be of very high quality in terms of machining and polishing. Of course, at such high RPMs, the slightest imbalance can lead to serious consequences. So, there are no complaints about the quality of the engine, its cooling, or the turbine itself. All the wires are exceptionally soft, multi-stranded, and in silicone heat-resistant insulation. The power wires from the battery are of gauge 16 AWG. The wires from the motor phases are 18 AWG. As for the drawbacks, I would note only these unsoldered spots, but they are easy to fix. The battery block itself does not have a protection system, also known as BMS. But I assume that this system is soldered onto the middle board with the regulator. Here you can notice a couple of power switches, and the power supply goes to the main circuit through one of these transistors. So it's quite likely that this is the BMS. On this same board, there is a small microchip in an 8-pin package with an erased marking. It might be the controller for the battery protection system, but that's not certain. The smallest board contains the brushless motor driver. It has 3 microchips and 6 MOSFETs for controlling the motor. All the capacitors are ceramic. Despite its tiny size, this board handles such large currents with ease and doesn't heat up significantly during operation. Perhaps the most noticeable heating occurs on the batteries themselves. And now it's time to figure out what kind of cells these are. So, let's cut off the heat shrink. Knowing that the Chinese are likely to cut costs specifically on the batteries, I already prepared a couple of high-performance high-current Samsungs 21700 with 5 Ah. But after removing the heat shrink, I was pleasantly surprised. They used LR2170LA cells from Leashen here. This is a top Chinese manufacturer of lithium batteries that works with many global brands and is known for quality products. So the cells are by no means low quality. 21,700 cells with a capacity of 4 Ah and a discharge current of 35 to 45 A. Depending on the discharge time, provided that temperature is monitored. Samsung would have given an advantage in capacity, but I won't be changing the cells for now. Honestly, I tried to measure the turbine's rotation speed with a non-contact tachometer. But there are many problems. The main one is that my tachometer doesn't measure more than 100,000 RPM. So, I apologize for that. We'll have to take the seller's word for it regarding the 110,000 RPM. What can ultimately be said about this blower? It might sound like an advertisement and praise for the product, I understand, but let's be objective. Here we have a decent charging board with quite a high current and support for fast charging protocol. The board is universal, and if needed, a module can be bought and replaced for a small cost. Next, the battery. The battery life is short, that's understandable. It's 185 watts of consumption, and with such dimensions, it's silly to expect some kind of miracle. But the very fact of using a pair of quality high-current cells priced at $6 to $7 each is pleasing. Each one is already pleasing. BMS system and brushless motor driver, they are there, assembled and work well. I can't say anything else about them. The quality of the engine, assembly and processing also impressed me. Such tiny dimensions, such speed and power. It's worthy of respect. They tried to make the casing microscopic and pack as much power into it as possible. Yes, nothing prevents you, for example, from attaching a separate box under the handle with a bunch of additional batteries if the battery life is insufficient for your needs. The Chinese know perfectly well that such a gadget will mainly be bought by car enthusiasts for cleaning snow off their cars. And the device should be compact for convenient storage in the glove compartment. And I believe that coming up with and making something better in such sizes is extremely difficult. It's also great for chasing away little rascals, but the device is only effective for the first couple of minutes. Then the little rascal develops an immunity, and the process turns into a game. And they will want more. After that, they'll take the device away and go play with it further. But without you. In general, to each their own, and I have acquired yet another trinket that will be turned on once a week to show off to someone. It's precisely for these purposes that I, like many others, buy such things. But, of course, not many will admit it. A bonus for those who watched until the end. Even before buying this thing, I developed my own version of a more powerful and versatile milking machine based on 4 cool servo turbo fans. The video will be released when everything is ready. And with that, today's video comes to an end. Don't forget to give it a like, dislike, or comment, share it with a friend if it was helpful, and subscribe to my 2 other channels where videos on electronics are regularly posted. That's all from me for today. As always, this was Kazi and K with you, and until next time, goodbye.